like this, but you only need to have 3 layers and 2 things floating for minimum points of 50 points, 1 point or 10 points for each thing. You can get up to 100 points, so that gives you 50 points extra credit. Moving on. So we've talked about milligram, gram, kilogram. Whoa. What about Instagram? Okay. All right, so we've done this, and you've had this forever, the scientific method. You've done science fair. If you were ever here in Utah, you did science fair in junior high, and you probably hated it. Okay? I'm sorry, they shouldn't have done it to you that early, because right now, science fair, if you do it on the high school level, can get you scholarships, can get you cash awards, can get you week-long or 2-week-long trips. I'm going to tell you a little bit about the things that you can do. When I was in high school, I did a bacteriological study on Farmington Bay. Back then, they wanted to turn it into a freshwater lake, just like they did Willard Bay. I thought, cool, that's right near my house, that would be awesome. And so I started researching it. And I ran into a brick wall. And then my science teachers knew that I was wanting to do that, so he said, well, how about you talk to this person at the State Geological Survey? I said, great. I talked to him. He also hooked me up with Weber County Health Department. Between the two of them, I got to use airboat. I got to go out on the lake with an airboat with them. I got to get samples with core drills. I got to go to the Weber Health Department. They helped me run tests. I had help, okay? But I got to research what I thought was cool. Now, because of that, usually we have 3 layers of science fair: school science fair, district science fair, and then you actually go to international science fair, where people from all over the world go. Okay, so it's a big jump between regional and here. Well, not very many high school students do science fair, so we usually don't have a science fair at the school. We just send you directly to regional fair. Well, at regional fair, I won first place. So they paid my way for a week trip to international fair, which was awesome. And I got to meet people from all over the world. I also got a full ride scholarship from Weber State, which was awesome. They now are offering not only full ride to Weber State, but Westminster is offering $50,000 scholarships at the regional fair, plus cash awards. When I went from the regional fair to the international fair, I won 2nd place overall in my division. From that, I went a 2-week trip to London for a Science Youth Fortnight there. Met people from Scotland and France, and we went all over in France and Scotland and England, and it was really awesome. I also went a week-long trip to White Sands, New Mexico, and people go, yeah, whoa, White Sands, exciting place. But it is exciting because it's a research facility, and I got to hang out with scientists and learn the new stuff that was just coming up, which was amazing. I also won cash prizes. So I had my school taken care of, I had cash prizes, I got trips, all because I did a science fair project. Okay? At a high school level, there's a much more things open. There's actually job opportunities. I was offered jobs too, but I'm a homebody, and I wanted to stay around here. It was in the Gulf that I was offered through the naval offices, a job down there, working with the oceanography. So don't shut that idea off. If you're thinking about or have thought about doing science fair or have something that is interesting to you, please come see me, and I will partner you up with somebody in the community that can help you, because you can't do it by yourself. I mean, you can, but it's expensive, and why do it when you've got all these people have access to all the stuff that you don't, right? So let me know. So we've done this before. We've done purpose, research, hypothesis, experiment, analysis, conclusion. We're going to go through the parts of that for the labs that we're going to be doing. We're basically going to ask a question. We're going to do some background research because we've got to learn something about it. We're going to create a hypothesis. What is a hypothesis? That's a fancy word. It's an educated guess. Well, I can't do an educated guess unless I'm educated, so that's why the background research. Then I'm going to conduct the experiment. Then I'm going to analyze it. I'm going to do some stuff, and we're going to talk about each steps. Then we're going to communicate your results. This is the part where I've been having you say, I need 5 sentences on your lab, and they were easy labs. I've been watching you to see how you're doing on those, to see if you're really thinking about it or if you're just going, yeah, cool, done. Tells me really well which ones are going to be my A students and which ones are going to be my strugglers. Okay, so if you're one of the strugglers, you need to sort of listen to this lecture really well today so you can get those ideas for at least those 5 sentences. That's the minimum. More would be better. I like to think of it like, you know, in English they make you do that 5-paragraph essays all the time. What's that 5th paragraph? What do you do in that 5th paragraph? Summarize. That's what a conclusion is. It summarizes everything you've done. Everything you've gathered in data, everything you've done in analysis, it summarizes everything you've done. And you put your ideas in there. Because of everything I did in lab, this is what I now believe. All right? You have another little chart there that has pies, looks like pies. And you start with observation, you go to hypothesis, and then you go through this testing cycle. And after you've done through the testing cycle enough, you end up with a theory. And once you've got that theory, then you do more tests and more tests and more tests, and finally it becomes scientific law. So there's a lot of testing that goes on before we get to a law. So let's talk about the lab write-up. This is on your next paper. I'm not going to write anything on the board. I'm just going to talk. What you need to do is take what I'm telling you and write it down in words that to you make sense so that you can write up your labs well. All right? The first thing is we're going to start with a problem or observation. We're usually going to do a pre-lab. The pre-lab is usually going to be done the day before we do lab. Next time we're doing a lab, I'm going to take you through the whole thing. So we're going to do the pre-lab, lab, and post-lab all in one day. But for our bigger labs, we can't do that. You're going to get the pre-lab the day before. We're going to talk about lab. We're going to come in. We're going to take a quiz on the pre-lab. We're going to go to lab. And then when we get done, we'll probably be finished just as the bell rings. The next day, we'll come in and do a post-lab. Okay? So that's usually how it's going to go. So we're going to have an observation, problem observation. We're going to have to read in here with the problem observation. We're going to have to do some research. Sometimes you'll be pulling it up on your phone. Sometimes you're going to be pulling up on the computers. Sometimes I'll give you a section to read. Okay? You're going to need to do that before you come up with an educated guess, which is your hypothesis. Okay, so you're going to have to do some research before you do your hypothesis. The next thing is going back into lab and actually performing the experiment. You need to know some things. You guys heard about dependent, independent, and controls before. Okay, controls are sort of straightforward. It's something I'm going to control, I'm not going to change. Independent is the thing that I am changing. Independent is the thing that I am changing. It's the thing that I'm going to manipulate in lab. So I'm going to change the temperature, or I'm going to change how much of this substance I'm putting in. It's the thing I change. The dependent variables are the things that change because I changed the independent variable. They're dependent on the independent variable. Okay? They're dependent on the independent variable. So dependent variable is the thing that that because I changed something, this changes. Anybody need me to repeat this or go over it again? So I'm going to be asking you, part of the pre-lab might be, before we actually go in lab, okay, when you come to take your quiz, what's the dependent variable? What's the independent variable? What are your controls? Okay, that might be an easy quiz right before you go into lab, if you've read the lab and know what I'm talking about. Now, on my quizzes, almost all of them are open note. Okay, and I don't know if I told you that before. My quizzes are open note. They're not open neighbor, they're open note. Okay, so if you take good notes, you can go back and look at them. All right, I think that was it on that page, yes. Going to the next. Typo observation or recording data. We have qualitative and quantitative. Anybody ever heard of those? They're really close together in sounding. Qualitative and quantitative. Anybody have an idea of what one might mean compared to the other one? Think of the name, yes. Okay, good. She's saying quality is how good it is or that, and quantity is how much I have, which is close. Qualitative is your observations, things that you can observe. Color, bubbling, how it's reacting, anything I can observe with my eyes, okay? Quantitative is numbers, the weight, the temperature, the how much I have of something, the volume. Those are all quantitative. So quantitative is a number. Qualitative is how it looks, okay? So I'll be asking you, what qualitative data did you pull out of lab? What quantitative data should you pull out of lab? Okay, does that make sense? Yes. All right, so analysis. Before we get into graphs, there's one thing we need to add to that. Analysis is any computation I do. That's a big word. What does computation mean? Add, subtract, multiply, divide, right? Any kind of that I do, that's part of analysis. So if I have to do any of that, that's part of analysis. Graphs are also part of analysis, and you need to be able to choose and be able to draw a graph. Now, this bar graph is set up numbers of people versus types of animals. Okay, so when I say this to this, it's y to x. Okay, does that make sense? They always say y to x. Even though it doesn't make sense, you want to say x to y. When you put it in, it is y to x. So what kind of pets do you own? This makes sense to do a bar graph because it's comparing different things and how many numbers of each I have. Okay, so it makes sense to do a bar graph. This pie graph makes sense if I'm working with a whole amount and I'm trying to find how much of that whole amount is different things. So students' grades, how many A's, how many B's, how many C's, how many D's. Sorry, there were no F's in this class. Okay, oh, darn. There's also line graphs, and we use line graphs a lot. Line graphs, again, number of teens versus age in years, Y versus X. And keep doing this because one of your problems says make a graph this versus this, Y versus X. Okay. Small town teens with cell phones, years. So usually when we're doing this kind of graph, we're doing time on the bottom, and something on the side, pH or something else. Okay. If I'm trying to graph two things, I need to make sure that I have a key. And I've color-coded or changed it somehow. So let's review really quickly the 4 parts of a graph that you need to have. You need to label your x-axis. Don't just put the numbers there, but you need to label it. So numbers and labels for both the x and y axes. It doesn't help me if you just put randomly marked things and don't tell me what you're doing. Okay, so it needs to have labels. You need to give your graph a title. Tell me what it's about. Give me a title. And if there's more than one thing on there, you better give me a key. Tell me what each line means. Okay? Now, I've been trying to pound this in your head. Conclusions, 5 sentences. Again, it's like that 5-paragraph essay, that 5th paragraph. It's your summary of the whole lab. What's going on in the whole lab? How did the whole lab go? Okay, what did you learn from it? What things were an aha moment? What things, happened during the lab? And then your error analysis. What could or did go wrong? Now, there'll be some labs that you'll go back in lab, you'll come back out here, you'll do your analysis, you'll do your conclusion, and I'll say, okay, here's the right number you should have got. And you'll go, oh, shoot, I'm not even anywhere close to it. So then you're going to do a percent error analysis. Percent error analysis is, and I'm going to give you the redneck version first. The redneck version is what I should have got minus what I got divided by what I should have got times 100. Okay? So you always absolute value what I got minus what I should have divided by what I should have times 100 to get it into percent. Okay, we just want to know how far away from the answer you really were. We're not worried about which direction. If you go up in chemistry farther, we'll worry about which direction you were farther off. Okay, in a lab, we don't want to be greater than 20%. So if we're greater than 20%, we've got a lot of talking to do before the boss just kicks us out the door. If we're under 10%, they'll usually offer us our yearly raise. If we're under 5%, they usually offer us a bonus. Now, if I'm above 100% in my error analysis, I'm out the door. Okay? So, you need to be talking here. What could or did go wrong? If there's a number we want to probably find an error analysis, a percent. When we're talking error analysis, we need to use specific words. And those words are, not going to be going on that, are precision and accuracy. And I want to play a game with you because, you know, talking so much, get bored. So I used to play softball once upon a time. And we're going to play softball. Who's a good catch? You're what, Kevin? You're a good catch? Okay. All right. He's going to be my center of my bullseye. Now, I used to be a good softball player. You guys all better keep your heads up and your hands ready to catch. You ready? Okay, I'm going to shoot for you. Ready? Good catch. Sorry. Okay. Was I accurate or precise? No. Okay, go ahead and throw them back up. Sorry. Woo! 2 in. Okay, I'm going to try again. You better keep your eyes open. You're funny. Okay, ready? Ready? Okay, was I accurate or precise? Precise. What is precise then? Same area. Okay, go ahead and throw them back. We'll make Elvis go out and I know. Where'd the other one go? There were 3. I had to do that because he caught the first one so well. Yeah, these are not very good to catch. Okay, so I was accurate and I was, no, I was not accurate. I was just precise, right? Okay, I'm going to try again. I'm going to get there, right? Watch your head, people, angel in front of you. Okay. Okay, what was I then? Was I accurate and precise or just accurate? And precise. Okay, I'm going to do it one more time. Ready? He's like, okay, I'm not going to put anything down. Ready? Okay, what was I there? I hear everything. What was I? I was precise? Ooh, was I accurate? I hit him once. I was accurate one time. One time. I hit the right thing once, but my other 2 were not accurate or precise, right? So I have to be careful with it. When we work in lab, it's all about numbers. So if my numbers are close together, I'm precise. If my numbers are correct and close together, I'm accurate and precise. If I get the right answer once and screw up the rest of the time, I was accurate once, but I'm not precise very good. In other words, I don't do the same thing over and over very well because I keep getting different answers, right? Okay, so tell me what's happening here if I have a gun or a bow and arrow and I'm shooting at the club. What's happening? What's wrong? I'm not accurate, precise, but what's wrong with my gun or my bow and arrow? So what's off? My sights. My sights are off, so I need to adjust my sights. So in lab, that's like I'm doing the experiment the same way every time, getting the same results, but I'm doing something wrong the same way every time, okay? If I am accurate, I did something right. If I'm accurate and precise, I'm doing it right over and over again. Does that make sense? Okay, let's go on. All right, chemical and physical properties and changes. Let's go over some of these. A physical property is sort of like qualitative. How can I describe something? Okay, so it has to do with color. It has to do with melting point. I'm going to shortcut that, MP. It has to do with boiling point. It has to do with phase. And when I'm talking about phase, I'm talking about gas, liquid, or solid. What? Okay, so physical properties. When does it boil? When does it melt? When does it freeze? When does it... what does it look like? Okay, texture, stuff like that. A physical change would be like tearing paper or cutting wood, cutting, sawing wood. Okay, I still have paper if I rip it, just smaller pieces of it. I still have wood if I cut it, just smaller pieces of it. So I haven't changed the composition. A chemical property, the way I remember this is how it will react. Not that it is reacting, but how it will react. So for instance, copper will react with oxygen and water to make patina, which is that green coating stuff. Okay? Potassium, when I put it in water, will react with water, and I'll get a purple flame and sparks, and it'll finally give me a final little explosion. Cesium, if I put it in water, will give me an explosion immediately, a large one. Okay? Salt, when I put it in water, will just dissolve. Those are properties. Okay? Now, change, chemical change is burning wood. So if I burn wood, I now have charcoal, right? There's no way I can turn it back into wood. There was actually a chemical change that took place. A chemical change would also be before you go to PE and after you come out of PE. There is a chemical change that took place, usually an odor change, right? Okay. Another one would be silver turning black or oxidizing. That is when it's hardishes. It's like silver rust. So copper rust turns to patina, it's green. Silver rust turns black. Iron rust turns red for iron oxide. There's a chemical change. It actually changes what it looks like. So when I look for chemical change, I'm looking for a color change, bubbling, a temperature change, meaning it gives off heat or it takes in heat. So if any of you worked in sports, cold packs or hot packs, when you activate them, there's actually a chemical change that's going on in there. Okay? All right, so I should be able to give you a scenario and say, okay, is it chemical change, chemical property, physical change, or physical property? You should be able to tell me. Okay? All right, density is mass divided by volume. I like to look at this way. Here's your heart, right? Your little dance if you're in love. Aww. Because here's your heart. Mass over volume. Okay? Got it? All right, so we're going to be doing a density lab next time, and we need to be able to do density with things, objects that are weird shaped. So if I wanted to find the density of this object and it was waterproof, I can't really use a sphere because it's not really a sphere, it's got little indents. So I would want to submerge it and do it by displacement. So what I do is I read off the graduated cylinder, what it was to start with. I put the object in, and I see how far it's changed. I take the new volume minus the old volume, and I've got the volume of my unknown object. Okay, that's known as finding water by volume displacement. Let's do some examples. I know. Okay, so what is the density of the metal that occupies 3.4 centimeters? And I never was really good at story problems until I had a math teacher that says, you know, it's just like regular problems. If they gave it to you, you just got to pull it out. So as you go, say, all right, this right here is going to give me what out of my equation? I had density equals mass divided by volume. What part is that going to be? Well, it's going to be this part, right? What's writing here. It's going to be the volume. So I'm going to put a V by it. So I remember that's my volume. And then I've got my mass right here. So this is my mass. So I'm looking for density. So I just pull the problem apart and say, okay, what do they want? What do I need? So to find volume, volume of a cube is length times width times height, right? So we're just going to times it through. 3.4 centimeters times, oh, I hate using those because it looks like X, times 4.5 centimeters times 5.6 centimeters. I'm going to plug it through our calculator and get an answer. Hopefully you've all got your calculators out. If you don't, they're in my sink. You better grab one because we're going to be going through them like crazy. I need to move that recording. Okay, so let's times that through. What do we get? 85.68. How many significant figures did I have? How many did I have? 2, 2, and 2. So I can only report 2. So I'm going to say 86 centimeters cubed, right? Centimeter times centimeter times centimeter, centimeter cubed. And this is my volume, right? I have my mass up here, so now I just plug it into the density equation. Mass divided by volume, and I get my answer. How many should I report my answer to? 2. Okay, reason why, here I have 3, and here I have 2. So I should only report it to 2. Is it going to be before the decimal or after the decimal? Big number, small number? Small. 0 point what? Give it to me. 2 after the decimal. Plug it through. What, you're making me work? 0.66 grams divided by centimeters cubed. Is it broke? Is it battery dead? Here. Try that one. I haven't replaced any of the batteries over the summer, so. All right, so we need to make sure we put a circle around our answer, and we've got the answer. Let's go on to another one. Okay, what would the volume, I'm looking for V, with a mass and a density. Okay, so I know that density equals mass divided by volume. And if I'm trying to find volume, I'm going to multiply both sides by V, right? V is going to cancel over here. And then I'll have to divide both sides by D. And D's will cancel. That looks really confusing, so I'm going to rewrite it. Volume equals mass divided by density. Basically, these two just switch places. Okay? Plugging in. 6.54 grams divided by 1.23 grams per milliliter. Grams cancel. And we end up with 1 over milliliters, which is milliliters. And how many significant figures? 3. Good. So what is our answer? What? 5.32 milliliters. Is that what everybody got? Okay, look at the next number. Is it one that you would roll up? Okay, so 5.32, and we're done. Okay? Next up, what would the mass, so this time I'm looking for mass, of a piece of plastic with a density of an irregular shape, so I'm going to have to do it by displacement, with a cylinder, and I'm a visual person, so I'm going to do a cylinder. It started at 200 milliliters, and it increased to 278 milliliters. So I just have to subtract that to find out 78 milliliters is what? Volume. Good. Okay, so this time I'm looking for mass. Wait a minute. Density equals mass divided by volume. I'm looking for mass. So if I times both sides by V, then that mass will be alone. So density times volume, right? Everybody okay with that, or do I need to show how I got it? Good? Okay, so now I'm just going to plug in. Mass is equal to density 3.542 grams per milliliter times 78 milliliters. Milliliters will go out. Mass is going to be in grams. How many significant figures this time? 2. Good. So times those together, what are we going to get? Be brave. What do you get? Okay, give me the calculator, throw up. Let's look at it. Okay, so I only can report 2 significant figures. 1, 2. So I look at this one, it'll round up, and then I replace that with a 0 because I have to tell you how big it is. So, whoa, 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 whoa. 280. Okay, do you understand why I did it? Okay, it's got to be as big as it needs to be. Okay, the rest of the time, okay. Make sense? Okay, daily work, your turn. I just love this little guy, this picture. Look at this. It brought me joy to see that picture, so I had to share. Okay, so get going on work. Daily assignment number 3. Bring the joy. We'll do lab next time. Make sure you're ready and prepared. Okay. Trinity locks. Yes. A what?
A highlighter.
A highlighter. Yeah. There's some right there. You can just put it back when you're done. Olivia's not here today. Olivia's not here. Or there she is. Okay, guys, remind me to close.